Hope you're all doing great. Let's continue with our topic 5.1 Antiderivatives. This video we will deal with integration formulae on trigonometric, logarithmic and exponential function. For more explanation, stay tuned with Hasna's Sparkwides. Let's learn how to compute the indefinite integrals. Last video, we learned how to deal with the power rule. Add 1 on the power and repeat the same power in the denominator. Don't forget plus c. This video, we will deal with the trigonometric functions integral sin x dx, integral cos x dx. If it is sine, it will be cos. If it is cos, it will be sine. Don't forget to add plus c. Also be sure if you start with the word c, feel it's so cold. So don't forget about the negative sign. So I repeat, integral sin x dx is equal to negative cos x plus c. Integral cos x dx is equal to sin x plus c. Okay, now let's move to the next two formula. Integral sec square x dx and integral cosecant square x dx. Again the same rule. If the answer starts with c, don't forget your negative sign. So sec square tan x, cosec square x, negative cot x. Okay. Now let's move with integral sec x tan x dx and integral cosecant x cot x dx. Again, when you are starting with c, don't forget it's so cold. So there comes a negative sign. Sec 8 tan, so sec x. Cosec 8 cot, so negative cosec. Don't forget your plus c. Now let's move with integral 1 by 1 plus x square dx, which is tan inverse x plus c. Tan inverse x means the denominator add. Then comes square root. Square root, yes, square root. So root 1 minus x square in the denominator will end up with sine inverse x plus c. Then integral 1 over modulus x root opposite x square minus 1, which ends up with sec inverse x plus c. Now comes the exponential. Exponential is always having what to say a constant. So integral e power x will be same e power x plus c, no change. Always they have a constant thought. You can have an idea like that. But if in the power you have a negative, don't forget to include the negative in the front as well. So please memorize the formula and use your own tricks and tactics to remember the formula. Usual in any function, distributive rule applies in antiderivatives also. Let's solve this question. Pause the video and try solving this question. Don't forget to comment below your answer, or at least you got the answer, or did you face any issues while solving the question, or you have any doubts. Please comment. Your comments help me to improve my teaching. Here we go. Since you have three terms in this particular function, first let us split it. X cube separately, 2x separately, negative 7 separately. Once you split, let's apply the power rule. What does the power rule says? Add 1 with the power and divide with the same power. That's how you got x power 4 over 4. Then you have plus 2. What will be for integral x dx? Yes, you are right. X square by 2. And the last one is very crucial. Negative 7. Integral dx is nothing but x. Don't forget. So you get the last term as negative 7x. Then please don't forget your plus c. You can simplify by cancelling 2. And your final answer is here. Hope you got the right answer. So let's move to the next question. Let's try this question. Please pause the video and try solving the question. Now let's check whether you got the right answer. First step, let's split it into two terms. Once you split, recall the formula. What is integral cos x dx? Bravo! Sin x. You are perfect. Now second term, apply power rule, which ends up with x power 9 pi 9 and don't forget plus c. Actually, this is the answer. If you want, you can write it in a standard form. Let's move to the next question. Let's try solving this question. As usual, first step, split it out. Once you split, recall the formula. What is integral e power x dx? It will never change, so e power x. Now negative 2 is already outside. What is integral dx over 1 plus x square? Perfect, tan inverse x. Don't forget plus c. So let's move to the next. Before we move to the next question, let's handle this formula. When you studied derivatives, we face this formula d by dx of ln x as 1 over x. Now the reverse. Integral 1 over x dx is nothing but ln x. Don't forget plus c. Now it's my favorite understanding. Integral f prime x dx over fx dx is equal to ln fx plus c. While handling the integration, whenever I see fraction, first I'll check, is the derivative of the denominator is the numerator. What? Is it the derivative of the denominator? Derivative of the denominator, is it the numerator? If it is the numerator, I'll just close my eyes and write ln fx plus c. Okay, so with this, let's continue to the next question. Try this question. Look at the denominator. What do you have? Yes, tan x. What is the derivative of tan x? You are correct, sec square x. So actually, your d by dx of denominator is same as the numerator, right? In that case, what is your understanding? Ln denominator. So here you will get ln tan x plus c. Remember, your derivative of the denominator is numerator. You just move with ln f of x. Let's move with the next question. Well, some functions we won't be able to evaluate, so be careful and alert. First function, the denominator you have cube root of x square. You can rewrite as x power 2 by 3. Since it is the denominator, you can take it to the numerator as negative 2 by 3. So we rewrite our step like this, then apply the power rule plus 1, simplify, flip the denominator, and you get the final answer. If you have any confusion, any doubt, please comment below. Let's move to question number B. If you notice here, we don't have formula for integral sec x dx. We have it for integral sec square x dx, but we don't have for integral sec x dx. Also, if you try writing this sec x as fraction, Still, you won't be able to apply len concept. So we conclude cannot be evaluated at this point. Here, if you notice, what is the derivative of the denominator x squared plus 1? Yes, it is 2x. So you can apply the len concept as the numerator is the derivative of the denominator. If you notice this particular function, you can divide the first term by the denominator x, also the second term by the denominator x. So you get integral x cube over x, which is x square, and second term as 1 over x. Now what is the derivative integration of x square dx? It is nothing but x cube by 3. And you remember the formula integral dx by x? Yes, you are correct. Len x. So the final answer is here. This particular function takes you to a concept of algebraic identity. What is a plus b times a minus b? Yes, a square minus b square. So let's apply here and you get integral x square minus 1. What is integral x square dx using power rule? X cube by 3 minus x plus c. And the final question over here, we can't evaluate at this point of time. So that's the end of this video. Hope you like it. If you like it, please like, subscribe and share and keep watching Hasna Spark Vibes. Thank you and bye-bye.